Okay, welcome to Chapter 5, Review, Rigging and Mechanical Installations for the Power Transmission class. This is one of the best chapters in the book in terms of robust content. We're going to really hit strongly on some of these. A lot of this is probably going to be new to you, even if you've got some experience in the world and in industry. For me, this is basically, I got out there as an engineer and I did a lot of this work without the correct education in this material. So I should have had this book when I first started doing work out in industry, and I didn't. So I had to learn all of these by trial and error. So this is a great book. The one thing we're going to do that I'll say ahead of time is we're going to spend only a light review of the formulas for performing weight estimations. We do not need to grind through all these formulas as part of this class. It is not something I want you to do as a beginning mechatronics student out there in the field. I don't want you to try to run formulas to do weight distributions. I want you to rely on the experienced members of your teams do that, or your engineering directors to do that. So let's hit on some of the key things. Number one, we're going to talk about why you want to balance your load. When you're lifting, it's critical to have good balance. If you don't balance your load, then you might have a point that you are attaching to the load that has much more force on it than it should, and it might snap. So that's very, very important. Or if you're having a single point lift, it might flip over. Also bad. Terminology is going to be key. As I've kind of outlined in many classes in mechatronics, if you speak like you know what you're doing, you know what these terms mean, then you can communicate effectively with other members of your team, and you sound smart and people want to work with you. So terminology is key. We're going to spend some time on wire rope. Wire rope is another term for steel cable. Wire rope is the proper term for steel cable. Wire rope is just like it sounds. Instead of having strands of fiber like fiber rope does, it's got strands of wire. We're going to talk about chains. That's important too. Chains are probably the most common use of rigging out in general purpose world. You're going to see that all over most plants. You're going to see it all around any kind of construction. You're going to see that in the farm. Chains are probably the best general purpose tool for lifting. And lastly, I'm going to emphasize pre-lift planning. Plan for the lifts. Unless you're just lifting something with a forklift that's a pretty ordinary load, you have to think about the steps that you're going to have when you lift that thing. So that's just what we're going to start with. So, book review. The first section, 5.1, talks about formulas and weight estimations. And in the first section here, it just talks about units of measure for length. Great. You guys should all know that. Scan through the table. That's useful information. And it talks about some conversions. Useful, interesting. You should know the table's there. You might want to use this table later on when you do some calculations. The book also talks about basic calculations for area and volume. And it gives you area and volume calculations for a variety of shapes. Cylinders, spheres, parallelograms, squares, rectangles, and a variety of formulas. I'm not going to quiz you necessarily on these, though I do have a couple questions in the quiz that touch on these. I am going to ask that you scan through this section of the book and remember where it is in case you need these formulas in the future. And it goes through all these formulas, including triangles and parallelograms and trapezoids, and great, useful stuff. I'm not going to emphasize this. This is useful information, but I don't want you to use this tool for calculating your load, center of mass. Estimation is usually what you're going to run into. You want to estimate where the pickup point are on pieces of equipment, or the pickup point is, say, for a large, say a backhoe, if you want to pick up a backhoe and put it down somewhere else. But frankly, if you are at the backhoe level, this is something you're going to learn by experience. This is not something you want to try to run a calculation on. A backhoe has a lot of complex components. You have no idea how to calculate the weight of that engine on the backhoe versus the bucket versus the swing arm. You're going to rely on the backhoe manufacturer to tell you how to pick up that backhoe, or an experienced engineer. You, as a new engineer or a new mechatronics student, is not going to attempt to do that, period. Don't do that. Okay, so we've gotten through all that formula. This is, like I said, more formulas on spheres and cylinders. Very useful. Don't do it. Don't do it. We're going to get to section 5-2, which is load balancing. The vertical center of gravity is very, very important. You have to be able to pick up an object so that the center of gravity is in the middle of the object. That means that my vertical center of gravity is symmetrical. So I'm picking up above my vertical center of gravity. Right? If something is very light on one end and very heavy on the other end, then I need to shift my lift point over towards the heavy end. Center of gravity, read through the definition. Center of gravity is looking at the weight and the position. Center of weight is more talking about something being top heavy or bottom heavy. Right? Center of weight, if I've got something that's very top heavy and I lift it from the bottom using a sling, then it's going to flip over easily. Like if the sling is not cinched down, if I don't use a choke hold on that sling, and I've got something that's very top heavy, and I'm just a little bit off on my center of gravity, then that center of weight, that top heavy item, will fall over and pull it right out of that sling. So I have to be very careful to try to lift things directly over a center of gravity, and or try to lift things that are top heavy as little as possible. So these are two very important terms. Center of gravity, center of weight. Vertical center of gravity, center of weight. They're talking about two different things. All right, section 5.3. In section 5.3, we start talking about the slings themselves. Slings are ways that you can grab the object that you want to lift. Often we make a sling to grab the object, and then we bring down a big hook for a hoist of some sort to lift that object. So we first learn about slings. And there's two key controlling things about slings. First of all, I want to mention OSHA standards. 1910-184 talks about your OSHA standards for slings. So you hopefully already familiar with this standard, and you already understand some of the rules around slings. They have to be they have to meet certain OSHA regulations. They have to be inspected in good shape, and we're going to spend some time looking at the OSHA regulations in the OSHA class. But the key thing is we're also going to talk about inspections. Inspections are critical. So sling terminology is also important. They use different methods of tying slings to different objects, and they each have different effects. A basket hitch, and we're going to look at the pictures on that later, is a way of looping around a sling gently around an object to lift it. It's a great way of lifting objects that are bottom heavy, and a great way of lifting objects where you've got multiple baskets on the object, especially if you've got a spreader bar lifting so that you can have 2 points of lift one on each basket when you're lifting something up. It's a nice, gentle way to lift something. However, if you've got a problem with one of your baskets, it's got a lot more load than the other, you could have a breakage. If you've got a top-heavy device, the basket simply won't hold the thing in place. It'll flip out of that basket. Another key term is master link or gathering ring. This is a point where your basket hitch comes to one point. Angle of loading is another key term. Angle of loading is very, very important because as soon as I have a basket that's holding up a heavy object and then I angle in as I'm going up to a gather point, that angle can reduce the amount of load that I can put on that sling. So anytime I have that sling wrapping around a hard corner, I am reducing that sling's capable load because that hard corner creates a especially high forces of tension on my sling, and the fibers can't do what they're designed to do. A choker hitch is another sling technique. It allows that hitch, as you lift that object, to tighten down on the object. And another term is proof load. You'll see that in here. So I'm just going to emphasize those terms. Very, very important terms. These are all part of the calculation slides. These are part of your center of gravity or center of mass. Here they show an example of lifting something with very top heavy. If it doesn't lift perfectly evenly, because it's top heavy, if you're just a little bit off center of gravity, then it'll flip right over. So this drawing here shows you your choker hitch and your basket hitch. So your basket hitch side view, you simply have a nice, gentle sling going all the way around the object. This angle right here needs to be paid attention to because that angle will tell you how much you need to reduce the capability of that sling. So if you have a sling that can handle 1,000 pounds, you throw an angle like that on there, it can no longer handle 1,000 pounds. And we've got a chart to figure out how much less it can handle. However, when you're pulling straight up with a vertical hitch, then you get your full strength. In this case, you got a chain. That's a great way of lifting things. If you have a tie point, attachment point to be able to do that. And here are examples of choker hitches with different angles. The bigger the angle, the less you reduce the capability of that hitch in terms of that sling in terms of its maximum load. So we're going to get into exactly how to calculate the maximum load based on the angles later. But now we're going to dive into the different kinds of web slings. And these are all examples of web slings. I'm not going to take you through them. You probably will be asked to identify different web slings in the future. So remember where this page is. You'll need to look these up. I will mention one thing about these. You're going to see web slings where they've got a steel ring of some sort. These are triangles, not rings, but they've got a steel ring of some sort attached to one end, kind of sewn into one end, and other web slings that have loops. The loop ones are more general purpose. They can be used in choker hitches and a variety of other hitches. They're designed really to be lifted by relatively large area hooks, like the hooks you see over here. Or they're designed to be lifted by large rings or by themselves. These two at the top with their little triangles on the end, they're designed to be lifted by smaller hooks, by chains or other kinds of steel attachments, where you have steel hooks that are small grabbing the ends of those slings. So just a little mention of that. There's a couple of words about web sling load capacities. That just sort of repeats what I said earlier. That's important to remember. We also talk about round slings as a separate category. I don't think I've seen as many round slings out there as these web slings. So read through that. They're useful to know about, but I'm not going to emphasize that. Fiber rope and securing. I use rope a lot around the farm, around my general work, and I do a lot of lifting with rope. You're not going to find that as much in industry now. In industry, fiber rope, because you're relying on knots, because you're relying on the individual skills of the people using that material, you don't see a lot of fiber rope. But there's a good section on it. It's a very useful skill to have. I am actually an Eagle Scout, so I know all about the knots and pretty good with them. But we're not going to emphasize knots and fiber rope as part of this course. Unless you guys are interested, then we'll do a little Eagle Scout knot tying work in the lab, in some future lab that'll be fun and interesting, and a bonus, not a core part of this course. This is part of the round sling. Let's skip that. Fiber rope comes in a lot of flavors. You've got manila rope, which is your standard natural fiber. We also have hemp rope, which is becoming more common because it's actually a little bit stronger than manila. It's used a lot for nautical applications. You're going to find hemp rope used in traditional sailing vessels and things like that. So it's becoming a little bit more common. But for the most part, for fiber rope, you're going to find nylon, polypropylene, and that sort of thing. And they all have different loads. Nylon and polypropylene tend to have the issue of they can get melted easily. They stretch a little bit. So when you're lifting a load, they've got a lot of stretch. And that can create a problem because loads can bounce and stretch and that sort of thing. So there are issues with that, but they are still excellent tools. Both of them are excellent tools. Hemp, manila, and all the polypropylene and nylon ropes are excellent. They all have different uses in general purpose lifting. I will say this about rope. Generally speaking, when you're lifting anything, you want to have 5 times as much capability on your rope to lift than that rope can lift. In other words, if you're lifting 120 pounds, you want a 600-pound rope capability. So you want 5 times. And if you're going to lift a human being, in other words, you want to set up a lift to get the person up to a higher position or climb the rope to get to a higher position, you want 10 times the amount of capability in rope. So these are factors in rope use. End rope preparation is very important, especially for natural fibers. In fact, pretty much only for natural fibers. Rope whipping is a sort of a dead skill, very useful. If you guys want to learn how to do natural fiber rope whipping, I can teach you that as well as part of my Boy Scout skills. I am not going to go through all the knot tying in detail. It's useful, but not critical for mechatronic skills. If you are a camper or a hiker or a Boy Scout or kids within Boy Scouts, you may want to learn these things. Or Girl Scouts. Girl Scouts, in my experience, haven't traditionally gotten the same level of knot tying education as Boy Scouts. Hopefully that's changed since I was in the Scouts. So all of y'all learn to use knots. It's a very useful skill. And like if I get critical mass that want to learn that, I will teach some of that. All right, so let's skip to the section on this. Actually, let me